Okay, in this question, we are titrating tartaric acid. We do not know the concentration of it, but we do know both the concentration and the volume of lithium hydroxide, a strong base, to reach the second equivalence point. So we've gotten rid of both H's when we deliver 32 milliliters of 0.805 molar lithium hydroxide. So this is a diprotic acid, so we have a 2-to-1 ratio here. So it's not our typical 1-to-1 that we're seeing when we're doing ice tables and things like that. Ice tables will be that 1-to-1 because we're getting rid of one H at a time and we're writing that out. Here we have a 2-to-1 ratio. And so the best thing to do in these equations or these type of problems is to write out the equation. So we have H2, C4, H4, O6. We're trying to get rid of both H's, which will get us a C4H4O6, 2 minus. And to balance that 2 minus, we need 2 lithiums. And so we need a 2 here. And then this will get us 2 waters. No, that's in solution. So the 2 H's from here react with these 2 H's. There's 2 O's. And so we have 2 H2O's. So what this shows us is that we have a 2-to-1 ratio. So we're going to need that when we do our mole calculations, because to find the concentration, we know the volume, we need molarity, which is moles per liter. So that's what we're missing, is how many moles are involved in this titration. So let's figure it out. Let's figure out how many moles of lithium hydroxide were required. So we 0.805 moles per liter times liters to get into moles. Here we have milliliters. We need to divide that by 1,000. 0.032 liters. 0.805 times 0.032, 0.02576 moles lithium hydroxide. Now we see from our equation that there's 2 moles to every 1 mole of our acid. So we have 0.01288 moles divided by our volume. 79 divided by 1,000 is 0.079 liters. Divide that by 0.0, and we get 0.163 molar. So writing this equation out is key. The fact that it takes 2, and we could also write it as Li2C4H4O6. We didn't want to put it in solution. So the fact that we need 2 means we need a 2 over here, and that accounts for our adjusted molarity. So 0.163. There we go. We're making sure we're in liters when we do this and that we understand that ratio.